everybody, and welcome to another lesson from Mrs. John. Now, today's lesson, sorry it's quite late in the day because I was working through all my other classes and it's your turn now. And this is actually the last lesson to do with DC and capacitors, and this last part is about connecting pre-charged capacitors. So the thing is, if a capacitor is not charged, there's no voltage across it. But if you charge a capacitor, you know that a voltage builds up across the capacitor plates. Now, when you have two such capacitors which are pre-charged, that means they're charged, there's going to be a voltage across them. They could be connected either in series or in parallel. Now, if they're connected in series, they're connected positive to negative. We're going to look at what happens when they're connected in parallel. When capacitors are connected in parallel, the positive plates are connected together. Okay, so I'm just going to draw a diagram and I'm just going to give us some numbers so that makes it easier. So here are two capacitors. And let's say those are your positive plates and that's your negative plate, and they are connected together. And we'll just name the capacitors. We'll call one of them P, we'll call one of them Q, and let's give them some charge. Let's say capacitor P is a 2.0 microfarad capacitor, and let's say this one is a 3.0 microfarad capacitor. Let's say this is charged to 20 volts and this one is charged to 40 volts. Okay, so these are two capacitors, they're pre-charged and then they're connected together. Now what happens when they are connected together is that charge is going to flow from the capacitor which is at a higher potential to the one which is at a lower potential. So charges are going to flow from Q to P. Okay, and charges will flow, and when charges redistribute themselves, what's going to happen is the capacitance will stay the same, so the 3 and the 2 don't change, but they're going to acquire a common voltage because charges will stop flowing once there's no longer any potential difference between the two. So there are a couple of things that we need to find out. The first one is, what was the initial charge on each of these capacitors? What is the common voltage or the common potential that they both reach? And then finally, what is the final charge on each of these capacitors? Now, one of the things we have to remember is that when charges redistribute, no charge is lost. It's either on one capacitor or the other. But because the charges have to flow through wires to go from one capacitor to the other, some energy is lost. Okay, so energy is lost, and how is it lost? Wires, resistance, so energy is lost in the form of heat due to resistance in the wires. Okay, you just have to keep that at the back of your mind. So let's do this question, and first of all find the initial charge on capacitor P, the initial charge on capacitor Q. I'm just going to change that letter Q because Q is also the symbol that we use for charge. So I'm just going to change that and call it capacitor X. Let's call it P and X, okay? So that we don't get confused with any other physical symbols. Okay, so initial charge on capacitor. So the way that we calculate on this capacitor 1 is on capacitor P, initial charge is equal to capacitance times voltage. So that is 2 times 10 to the power of 6 times 20. 2 times 20 is 40, so I'm just going to write it as 40 times 10 to the power of negative 6 coulomb. Okay, then let's get the charge on capacitor X, the initial charge. Charge is equal to C times V. How do I get C times V? Because I know C is equal to Q over V, right, from that equation. So capacitance is 3.0 times 10 to the power of negative 6. Voltage is 40. 3 fours are 12. So it's 120 times 10 to the power of negative 6 coulombs. Okay, so that's the initial charge. Then, why am I getting the initial charge? Because I need to know what is the common potential or common voltage. So using this equation, C equals Q over V or V equals Q over C, we can get your common voltage is total charge divided by total capacitance. So my common voltage is charge on capacitor 1 plus a charge on the other capacitor plus capacitance of one plus capacitance of the other. So when you add both those charges, it's 40 plus 120 times 10 to the power of negative 6. And the total capacitance is 2 plus 3. They're both in microfarads, so that's also times 10 to the power of negative 6. So I end up with 40 plus 120 is 160 divided by 5. And that works out to 5 3s are 15, 5 2s are 10. Okay, it works out to 32 volts. That's a common potential. So now what happens is that the voltage across this capacitor is no longer 20. The voltage across that is 32 volts. And the voltage across this is also 32 volts. That means they both have the same voltage. And the next thing we can find out is what is the new charge after charge is redistributed. So in order to find the new charge, we use Q equals C times V. So on this first capacitor, capacitor P, it's the same capacitance, but now the V is your common voltage. And the charge on the other capacitor, there are two ways of finding out. You know the total charge. Total charge is the same. The total charge is 160 minus whatever this, and you get that. Okay, so capacitance 1 is 2.0 times 10 to the power of negative 6 times 32. 2 times 32 is 64 times 10 to the power of negative 6. Okay, and then the other one is 160 minus 64. That's one way of getting it. Or the other way of doing it is 3.0 times 10 to the power of negative 6 times 32. 32 times 3 is 96. 96 times 10 to the power of negative 6 coulomb. So that's the new charge on each of those capacitors. So that's how you do these questions. So just going over it again, when capacitors are pre-charged and connected to each other, the first thing that happens is that there is what we call charge distribution, and charge flows from higher potential to lower potential. If capacitors are in parallel, the positive plates are connected to each other, and charge flow stops once they reach this common potential. How do we find common potential? It's found by total charge divided by total capacitance. How do you find total charge? By finding out the initial charge on each of the capacitors using charge as C times V for each of them. And then because the charges have redistributed and each of them gets a new voltage, it's possible to do capacitance times the new voltage to find out how the charges have redistributed. Okay? You can also go a step further. You've got one of those questions in the question sheet where you have to calculate the total energy before and the total energy after and find out how much energy has been lost. And you know about the energy stored in a capacitor is half QV. So you can use half Q1 V1 plus half Q2 V2. That is when they were initially the total thing, energy, and then you use half the new value of Q and V to calculate the energy later. Okay, I've worked these answers out as well. So work your way through those questions And I've done a set of Google Slides with some notes on it, as well as I'll load this video too and see how you go. And I might make a Google Doc. If you have any questions, if you post them there, I will answer them. So that's today's lesson, the last lesson on DC and capacitors. Tomorrow's lesson, Thursday the 13th, is your lesson for the assignment on DC and capacitors, and I will post it as an assignment, and there are actually 3 assignments, so if you can have those complete at least by the weekend, it'll be nice. But I'm going to start the new topic on electromagnetism on Friday. Okay, so bye for now, and hope you're all safe and look after yourselves too.